Okay, folks, this lesson is going to show us how to find the absolute maximum or minimum values of a continuous function on a closed interval. So we call it the closed interval method. There's really 3 steps in doing so. First thing is you have to find the critical values of the function. So we'll need to take the derivative, factor the derivative, and find any values of x that make the function equal 0 or make it undefined. Step 2 is you find the values of f at the endpoints of the interval. So if you look down here in the example, you can see the function is f of x equals x cubed plus 6x squared plus 9x plus 2. But the endpoints of the interval would be -4 and +1, because we're only looking at this cubic function for x values that are greater than or equal to -4, but less than or equal to +1. We also have to find the value of f, so the function's height, at our critical numbers. Remember, the critical numbers would have to fall in between -4 and +1. And the highest of the values from steps 1 and 2 would be your absolute maximum. The lowest of the values from steps 1 and 2 would be your absolute minimum. So once again, just to clarify, I'm going to scroll down here. You'll see that I took the derivative, found the critical values. I'm going to plug those critical values back into the f of x function, this function down here, which I'll underline. And I also have to plug the -4 and the +1 into that. And the highest of those becomes my absolute maximum. The lowest of those becomes my absolute minimum. So you'll see when I find the critical values, all right, to do that, I take the derivative of x cubed, 3x squared, the derivative of 6x squared, 12x, the derivative of 9x, 9. So the f prime x, or the derivative of f of x, is equal to 3x squared plus 12x plus 9. Factor out of 3, left with a simple trinomial inside the brackets, which factors to x plus 1 and x plus 3. Now remember, this 3 out front here doesn't give us a critical value. But inside the brackets, x plus 1 and x plus 3, well, a -1 would make this 0, a -3 would make that bracket 0. So I have 2 critical values, -1 and -3, and I have 2 endpoints, -4 and +1. Now all I need to do is find the heights of the function at -4, at +1, and at -3 and -1. And you'll see that work down here. Okay, f at -1 is equal to -2, f at -3 is equal to +2. So those are my 2 critical values. F at -4 and f at 1 yield -2 and 18 respectively. Those are the endpoints of my intervals. And you can see what I've come up with here are 4 different points: -1, -2, -3, -2, -4, -2, and 1, 18. All right, the highest y value is the 18. So this becomes my absolute max. The lowest y value, I have actually 2 of them at -2. So these 2 points become my absolute min. I hope that helps.